Hello and welcome to the UK Bebras Coding Challenge training video. In this video we will be learning how to access, figure out the answers to questions from past challenges and learn the best and most efficient way to become successful at the UK Bebras Coding Challenge. But first, what is the Bebras Coding Challenge? Well, the Bebras Coding Challenge is a computational thinking competition. It contains fun, problem-solving challenges using logic and patterns, and you do not need to know how to code in order to participate. The Coding Challenge is an event for UK students aged 10 to 19 who took part in this year's UK Bebras Challenge. It replaces the OUCC as the next step for UK Bebras participants. It is important to note that the UK Bebras Challenge and the Bebras Coding Challenge are two separate competitions. The aim of the 45-minute coding challenge is to enhance your skills, build confidence, and inspire you to develop program solutions to computational thinking problems. Why would you participate in the Bebras Coding Challenge? There are several benefits of participating in the Bebras Coding Challenge. 1. Develop your computational thinking skills. 2. Practice your problem-solving skills. 3. Enhance critical and logical thinking. And 4. In general, it is fun and challenging. There are two groups of questions in the coding challenge. The first is known as Novices and the second is called Explorers. Novices is the first challenge level and it should be practiced and completed first. Explorers contains more difficult challenges and should be attempted after mastering the Novices section. There are also two categories of questions. 1, which is block-based, and 2, which is text-based. Block-based is where code is pre-written in blocks and you drag and drop them to create your final code and submit your answer. Text-based is where you write each line of code by hand using the programming language Python. In this challenge video, we will be training ourselves on how to be successful at the block-based category. This is where we will be given pre-existing code written in blocks and be expected to drag and drop them into producing the final correct answer. We will be looking at a past challenge with 10 example questions in review mode. As you can see here, the level of difficulty increases as the questions go along. So the first 4 questions are of increasing difficulty A, then B for the next 4 questions, and then the last 2 questions are of the highest level of difficulty, which is difficulty C. So let's start having a look at the first question called Draw a Square. So let's have a look at the first question called Draw a Square. In this question, the task is to write a program that moves the turtle so it draws the square shown in grey. Now let's look at the structure of the question and the website first. As you can see, in this area here, there is the question. And then on the side, you can see that you are given 3 possible blocks that you can combine together and move into the section here in order to create your code. Looking further down, you will see that there are 3 buttons. The first button is the one that you press to test and run your code. The second button allows you to go through your code step by step or block by block. And the red button here resets your code back to the beginning if you would like to start again. This slider section here allows you to speed up the execution of your code or slow it down. This is helpful if you are looking at some possible bugs or errors in your code and would like to slow down the execution of each block so that you can look very carefully as to where you may have possibly got an error. These sections here are specifically in relation to the use of the blocks, so they allow you to zoom in, zoom out, and remove blocks should you want to remove certain sections that you do not any longer need. Let's have a look at the question. The question here says you need to move the turtle so that it draws the square shown in grey. Now the first thing to do is look at the blocks that are given to you. In this particular question, you are only given 3 blocks. This means that there is not a huge amount of combinations of blocks that you can use or create in order to get the final solution. So the first thing you would do is move some of the blocks into the section for you to run your code and test it. Now, as you can see here, the blocks are pretty self-explanatory. This block here allows you to move forward or back, and if you change the value here, it changes the amount of steps that the turtle takes. The same concept applies to the next block, but in this case, this block allows you to turn the angle that the turtle is facing in, left or right. Again, the block section at the end allows you to change the number or the degree, in this case, that the turtle turns. Pen up and pen down allows you to stop the turtle from drawing on the canvas at certain points if you bring the pen up, and move the turtle to a different section of the canvas. And pen down allows you to draw on the canvas. So let's have a look at what some of the blocks do. Now, as this is a square, we know that our degrees are going to be 90, and we are going to be turning either left or right at 90 degrees. The first thing we need to do, as the turtle is at this starting point here, is move the turtle forward to the corner over here. So the turtle starts here. We need the turtle to stop here, and then we will need to use the turn block in order for the turtle to then turn the correct way 90 degrees and carry on. Now, to draw the square, we know that we will need to repeat the same blocks 4 times. This means that once we've carried out the first set of blocks correctly and successfully, it is simply a matter of copying and pasting, or in this case, if you right click on the blocks, you can duplicate your blocks as shown here. You can also delete blocks, disable blocks, and collapse blocks. So if you have a look here, we are going to practice with the given block, which is moving forward by 80. As you can see, when we get to the top corner, we do need to turn left 90. So if I click those 2 blocks together and run it, I can see that my turtle has managed to get to the halfway mark of the line. This means that 80 times 2, i.e. 160, is the full length of the line. Once I've changed this, I can quickly test it to see if that's correct. As you can see, my turtle is now in the correct location to move on the next line of the square. So let's carry on writing this code. Now we need to move forward 160 again. This is because we know that each line of the square is exactly the same. As you can see, I've used the duplicate function to allow me to quickly copy and paste the code and carry on working. Now, if I run this code to quickly test where I am, I can see that my turtle is now in the top left section of my square. Now in this case, instead of turning left like I did before, I know that I will be turning at a degree of 90, but in this case I will be turning right. So let's turn right. Oh, as you can see here, it should have actually been left. So let's change that and run it again. Now as you can see, this is a process of almost trial and error. It is possible that you will make some small mistakes or even some large ones. The idea is that you go through your code step by step, run it at each stage to make sure that you are going to the correct solution. So as you can see there, I've quickly modified the right function to the left, and I can see that my turtle is now facing in the correct direction. Again, I know that because my square is of equal sides and equal angles, I can copy and paste the code or duplicate the blocks in order to do the correct thing the number of times I need to. So if I run my code again, I can now see that my turtle is essentially on the last section of code, which is following the last grey line. Again, this means that I need to turn a certain location or in a certain direction. Again, I will definitely be turning 90 degrees. So let's test the left turn and check if that works. Yes, it does. Now the last thing left for me to do is to go back to my starting point and thus duplicate my forward by 160 and run that code all the way till the end. As you can see now, because I have successfully completed my code and it is doing what I want it to do, it tells me clearly here that it is correct and that my answer has been saved. Now, it's important to understand that for every challenge that you will see, there are possibly different answers and different ways that you can solve the solution. So in this case, if we look at the possible answers and explanations given on the website, you can see that instead of moving forward by 160 in one go, we've used here in the solutions 2 blocks where we're moving forward 80 and then moving forward another 80, which in essence is the same thing, but it uses an extra block and does 80 twice instead of doing what I did, which was moving forward by 160 using 1 block only. Either solution would give you the correct answer and therefore would be marked correctly. How did you find that question? Well done for getting through question 1. Now let's look at the next question called Battenburg cake. This question has a lot of information provided to us first that we must read and digest in order to be able to tackle answering the question correctly. So it says here that the scene shown below is of a slice of Battenburg cake. All the colours are faint so you can see what you are trying to draw. The task is to write a program using only one type of block to draw the image shown. The hints are that the image is made entirely from square shapes, which we can see there are 5 square shapes, including the orange square in the back there, and then 1, 2, 3, and 4. So let's highlight that carefully. 1, 2, 3, 4. That's my 4 squares, and then of course the 5th one is outside here. And then it says apart from one square that needs a radius of 32, all radius and position values are multiples of 5. And the next thing it says you only need to use the 3 colours on the top row of the colour picker, red, orange and yellow. So of course the colours are specified here. As you can see, it says we need to only use one type of block and we are only provided with one type of block. So we need to first, before coding the solution to this, fully understand every part of the block so we can make sure that we use the block to its absolute efficient method. So let's pull out the block here. Let's run the block as it is and see what happens. Now, as you can see, running this block creates a circle. This is because the number of sides is set to quite a high value. Now, because we know we are completely creating shapes made out of squares, we can go ahead and change the number of sides to 4 because of course we know that a square has 4 sides. Now, the color is self-explanatory. Of course, we'll be changing the color accordingly in relation to the squares that we are drawing. Now, because we've started off with a red square by default, let's attempt to draw that first top left square, which is also red. Now, of course, we can see that the square is almost in the right position, but not quite. And also, it looks a lot larger than what the square that is required is in relation to what we have. So now we know that in order to change the position and to change the size of our square, we of course need to use the 3 values that are on the bottom part of this block. So the first value we can see is radius. Now let's have a look. The radius 20 creates a square this shape. Let's have a look at the radius that's been given to us, which says 32. Run that and see what happens. Now we can clearly see that 32, which was larger than 20, has created a much larger square. Now let's understand what the radius actually is in relation to this square. Now, using our mathematical understanding, radius is a definition or a key term that we often associate with circles. So going back to the circle, you understand that the radius of a circle, I'm just going to create a circle for demonstration purposes here again. The radius of the circle is any point from the center of that circle to any of the edges. Now, the same concept applies to the square. So if we were to change this back to a square and draw it on our canvas, the radius is essentially the measurement between the midpoint section and any of the 4 edges of this square. So in this case, we could actually use the grid and ruler provided to us to roughly estimate and understand that this square has a radius of 32 because the measurements between the midpoint up to each of the edges is actually 32. So we could, again, for drawing purposes, we can use this. This measurement from here to here is 32. So is this. This is also 32 and this is 32. So if we wanted to draw the smaller square, because this square has obviously drawn us the correct size for that orange square, we could probably change this to the orange color and park that particular block on the side, because we know that that's almost done. So if we wanted to draw the red square, we could duplicate this block, and we could of course carry on using the features of the block to draw the red square. Now before we do that, in order to make our code organized and understandable, we need to rename our blocks. So if I call this one yellow outer, and then I call this red 1, then of course this will allow me to identify each block and its corresponding shape that it's trying to draw. Now, this particular square is the background square. So for now, I'm actually going to disable it, and I'm going to leave it there because it's almost finished. The only thing that needs to be changed is the position, because it's not quite being drawn in the correct position on our canvas. So let's run this. We now have started back off again with our red square. Now in this case, we know that the radius does need to get smaller, purely because we know that the radius of this particular square is much smaller than the background square, which encapsulates all 4 squares put together. So because the radius and position values have been told change in multiples of 5, let's try 20 for our radius and see if that gives us a shape that looks very much close to the shape size that we need. Now, we can change this further to 15 because I do think it looks a little bit big, and we can leave it there for now, because the only way to truly check if that square is exactly the correct size is to move it on top of the faint red square that has been provided to us as a guidance. So let's now look at the position X and Y values, because these are really important. Now currently, as it stands, the position X and Y values is 20 and 20. So my square is being drawn around that center point. So in order to use the grid correctly and to use the position X and Y correctly without wildly guessing too many numbers and effectively wasting time in our challenge, we can use the grid to sort of move our square into the correct middle point location, which is here, using those X and Y numbers. So if my X, or the middle point, is roughly here, I can draw a line up, and I can sort of draw a line here and say, but that's sort of like 30, 35. So if I change my 20 to 35, I can actually make a more accurate estimate to help me identify the exact location of where my red square should be. Now, as you can see, using that has allowed me to actually put it into the correct position in the first go. But even if you didn't do it in the first go and you put the number 30 or 40, that would have given you a much closer guesstimate in relation to the grid provided than going up in values of 5 or multiples of 5 with every possible combination. So it's important to understand that the radius, the X and the Y are values that are given to us to help us estimate where we should put our shapes quickly using maths rather than taking guesses. So now that we've successfully placed our first red square, it actually makes drawing the second red square really simple, because all we need to do is duplicate the square, rename it, of course. So I'm going to rename it red 2. I'm also just going to use the hide menu function to allow me some more space. And then what I'm going to do is I'm going to look at what I need to change using my knowledge of the features or the points in this square in order to move this square down to here. Now this is clear to see that the radius needs to remain the same. So I now need to use my understanding of X and Y to roughly plot exactly where that starting point is for the drawing of my square, and then use those values to help me identify the numbers. So I'm actually going to use 65 as a starting point and see what that does. Now if I put 65 and 65 in and run it, as you can see, using that process of drawing my midpoint, using my X and Y coordinates using the grid provided, I have been able to accurately estimate exactly where my position needs to be. Now, using the process of elimination, this is actually becoming much easier, because now I can go ahead and duplicate the red block in order to draw the yellow block. So let's just change the name to yellow 1 and then change the color to yellow. And now we know that the radius for all 4 blocks does absolutely need to be the same. So if I was to draw this, now you can see that the location X and Y just needs to change. So if I go ahead and use that method of the grid to identify, for example, this yellow block, I can see that it sort of hits sort of 30 and 65. So let's have a look. Let's try that out and then see what happens. So again, I'm going to zoom out a little bit, and I said the numbers were 30 and 65. Let's run it and see where my yellow block goes. Now, interestingly, the 65 seems correct, but actually my other number, 30, is slightly too far on the left. So I'm going to go back, and actually I can see that the number 35 has been used for position X before. So let's mirror that, and of course, using the fact that we need to go up in multiples of 5, let's put that in. And as you can see, that successfully put my yellow block into the correct location. So again, I'm going to hide the menu, and now I'm just going to use the process of duplication again in order to duplicate this block in order to create yellow 2. Now it's really easy to see that the numbers that we've already used for X and Y are really helpful. This is because the radius remains the same, but position X and Y are essentially the same position for this red block and this red block. So we can actually use the numbers that we've already used, or carry on using the grid if that works well, to identify the midpoint and thus the X and Y value. So I can see this hits 65, which also is a value that's been used already. And this sort of hits over here 35. So let's now move on and change the values from 65 to 35 and run this. And brilliant, we've now got our 4 squares in the middle. And as previously created and just disabled, we did actually create our outer block. So I'm going to just put that here and enable it and see what happens. But as you can see, it is still in the wrong location. So all now we need to do is use our understanding of X and Y coordinates and positions to move that particular square into the right position. So again, I can use my understanding of the grid. So this looks like 50. This also looks like 50. So let's change position X and Y to 50 and 50 and see what that does. So let's go here, 50. Let's go here, 50, and then run it. And then as you can see, I've got the correct answer, and this is exactly what I was looking for. So well done. Did you get that answer correct? How did you do? Let's have a look at the answer and explanation provided to us on the website. Now, as you can see here, the explanation says that in the key tips tutorial, it's often helpful when solving these problems to right click on some of the blocks you know are correct and disable them. Now, we did this specifically with the orange block, which was the outer block, because we used the radius given to us to help us get started. This will let you see the pattern beneath while you program in other parts of your image. This is the equivalent of a technique called commenting out in text-based languages, but is somewhat more elegant. So we use this method to disable the block at the top here as seen in the possible answer. And then of course we put it back in right at the end when we needed to put it in after looking at the other 4 squares which we needed to solve first. Now the key thing with these image questions is to make sure that the shapes you want to appear behind are drawn first. So in this case, one possible answer was pretty much similar to the way that we created the answer, was to create the orange outer bit, then the yellow inner bit, then the 2 squares on either diagonal side of the red. Now what we did is we created 2 squares here for the yellow and 2 squares here for the red and 1 final square here for the orange. But what you could have done as another possible solution was to draw a slightly larger radius yellow square, which was only slightly smaller than the orange square. Now what we did was used 5 squares instead, but as you can clearly see on the website, It says here that this is one possible answer. So the way we solved the answer still gave us the correct answer. So it is still correct, but this is also another way of approaching the answer and getting a different solution. Which solution did you come up with? Now let's have a look at the third question. This question is called purple star. Now in this question, we are asked to write a program that draws a purple star. As usual, we are given some information. The first bullet point in the information asks us or tells us that for more programming space, we need to use the hide menu button above. Secondly, it says your turtle will need to draw a triangle that has size 100. Let's have a look at how we would approach this question. Now, as you can see, our turtle's starting point is right in the middle of our canvas. Secondly, you can see that we have a star with 6 edges or 6 points that it is going to create. So let's have a look at the blocks. Now, as you can see, we do have quite a few blocks here, but our starting point is to draw a triangle that has size 100 because that is exactly what was given to us in the instructions. So let's pull out this particular block here called draw square 10, and let's have a look at the fact that we can change the shape that we are creating to, of course, the triangle that we've been suggested to create. Now, it's interesting because we can also see that there's an option here called star. So if we were to click on this and to change it to 100, it would be intuition as a human to think to yourself, well, that might actually solve the problem. So let's run it and see why it wouldn't be the correct answer. The star here automatically draws a star with 5 spokes. In our case, that doesn't satisfy the requirements because our particular star has 6. So let's go back and change this to triangle of 100 and see how helpful that is, as that is the instructions given to us in our information. Once I run that information, it is clear to see that there is one triangle that has already been drawn that is exactly in the right spot that we need it to be. Now, before we move on and figure out what the next thing is to do, we can use our mathematical knowledge to really help us identify exactly what we need to do next. This triangle has been drawn right in the middle of the canvas. It's important to understand that unless given specific instructions as to where to start drawing our particular shape, as default, the starting points will be the middle of the canvas. So as you can see, the turtle was right in the middle. As we didn't specify any other X and Y values using the blocks here, we know that our triangle has been drawn absolutely in the center of the canvas. So that solves the reason why the triangle here is exactly where it needs to be. It's quite clear to see using the faint drawing in the background that actually this star is made up of 2 triangles. Now this is interesting because now all we need to do is draw another triangle of the same size. However, we need to rotate the triangle a little bit more in comparison to this triangle here in order to create that second triangle. There's 2 ways to approach this. Of course, we could use the blocks provided to us, particularly the turn right block, and identify a specific number to turn and then draw another triangle as we want it to be the same size. So let's change that to 100. This specifically doesn't give me the right answer. So we could use trial and error to modify the number that we are looking at. So again, I could run this with 45 and see what happens. But because this is a challenge that requires speed and efficiency, what we could do is actually note the fact that we are working with 2 equilateral triangles. Now, using our mathematical knowledge, we know that the angles inside an equilateral triangle are all equal and are all equal to 60. So just using that mathematical knowledge, it would be helpful to use 60 as our starting point for our turn right value. So let's try 60 and see what happens. So I've already tried 90 and I've tried 45, bearing in mind that those 2 haven't been the correct amount of turning degrees as my triangles didn't fall in the right place. So now let's use our mathematical knowledge as opposed to using trial and error to create the final turning, which would make the correct triangle. Let's run this and have a look. As you can see, the mathematical knowledge here has allowed us to create the second triangle in exactly the right position in one go. So you can use the process of trial and error, but what you can also do is look at questions like this, particularly those that are using shapes with the grid and also with our mathematical knowledge to help us identify and eliminate certain numbers, that would be extremely helpful. In this case, 60 was our helpful number, again reiterating the fact that the angles within an equilateral triangle are always equal and each of them are 60. Did you get that answer correct? Did you use your mathematical knowledge? Did you spot that hint? Well done if you did. Now let's look at the solution provided on the website and see how it compares to our answer. So our answer is correct, and as you can see here, another possible answer, meaning there were multiple ways of doing the solution, is that one was to draw the triangle as we did, then to turn right by 90 degrees, turn right by 90 degrees again, and then draw the triangle again. So essentially you can see that there's an extra block here which turns 90 degrees once and then turns 90 degrees again. In our case, we used our knowledge of equilateral triangles and the internal angles that they have in between to identify that we need to turn right 60 in order to draw a second triangle exactly in the right spot without having to turn right twice. So either possible answer is correct. Which solution did you get? This question is called Greetings. The task here is to write a program that prints the text hello, hello, hello. As usual, we can use the hide menu button to create more space. And then the second bullet point here again is our very key and important information that tells us the start position for the writing is at 100 for X and Y is 200. So first of all, let's look at the blocks. As you can see, we have quite a few number of blocks to work with. But the first thing that is really important to identify is that the starting position is given to us because the starting position on the canvas here is in the middle, which means it isn't in the correct place to start writing from the first H for the first hello. So the first thing we need to do is set that position. So as you can see here, there is a block that allows me to change the position of the X and Y location. So let's use the hint given to us and make X and Y 100 and 200 respectively. If I run that quickly, you can see that immediately the starting point for the text writing is now in the correct position. Now let's go over and use the display text block to display our text. So in this empty box here where the speech marks are, I'm going to use that section to write the message that we need to have, which of course in this case is hello, hello, hello with an exclamation mark. Now, if I run that quickly, you can see that it does correctly start in the right place and it does correctly print the right message, but in this case, it's not going in the correct direction. So this is quite a simple fix. What that means is you need to rotate the location of where your writing starts from to turning right at a 90-degree angle. So as you can see, I've dragged that block over. Let's have a look. And as you can see here, I have successfully and correctly answered this question. Now let's have a look at the solution provided by the website for this question. As you can see, the answer is pretty much exactly the same as the one that we've done above. The only difference here is that the font size, and some of the features of the font have been modified. But the logic behind the answer that we have created and the one in the answer is exactly the same. X and Y positions have been set to those given to us in the question. You've then turned 90 degrees right and displayed the text as provided. Well done if you got that question correct. Let's move on to the next one. Let's look at the first question in difficulty level B challenges called Battenburg wallpaper. Inspiration for a new wallpaper design came while eating Battenburg cake. The design consists of squares made from the two colours shown on the right, this one here and this one here. The task says to write a program to draw the pattern shown faintly below. So the first information point is, as usual, to create more programming space, use the hide menu button above. And then the second bit of information says you will only need to enter variable numbers that are multiples of 10. So let's first have a look at the design. You can see that the design is similar to one we've seen before, which was the one in the Battenburg cake challenge. However, this design only has 4 squares, and in this particular question, we have been told exactly what shade to use as opposed to the normal default red and yellow values. So because we've been told what to use, let's go over to the blocks and have a look at what blocks we have. Now I can see that I have some set color blocks. So what I am going to do is, to make sure that my answer is of course correct in relation to the colors, I'm going to set my colors now. So the first color is this particular red over here, which is one down from the one that it's set to. And then this particular yellow is the third one on this row here. Now, we know that at one point we are going to be creating red squares, and then we're going to change over and create yellow squares. Now, there are multiple ways to approach the changing of colors and the drawing of squares, but again, we do want to try and create solutions that are as efficient as possible. So in this case, what we will do is we'll draw the red squares first, and then we'll draw the yellow squares. So we're going to leave the blocks for changing colors organized in that specific way. And then what we are going to do is we're going to use our understanding of exactly where our squares need to be drawn in order to draw the squares in the correct place. Now, as you can see, our turtle is actually in the middle location, 200 and 200. So if I was to go over to the turtle and if I was to draw a square of size, for example, 50, you can see that it's going to draw a square that 1 is too small and 2 is in the wrong location. This means that we need to move the positions using the X and Y coordinates first before we draw the square. So let's actually go ahead and move our turtle in the right positions. So you can see here, again, we've got position X and position Y. Now, using our understanding of the grid, we can identify that to draw the positions accurately, the middle point is where our squares will be drawn from. So I can see this is 150 and 150. So let's have a look roughly if that helps us draw the square in the right section. So let's draw the square of size 50, which we know is too small, but let's test that anyway. As you can see, the location of the square is now correct. Now we just need to use the background lighter shaded red box to help us draw the box in the right shape. So let's increase the size to maybe 70. Again, it does say you need to change the variables in multiples of 10, so you won't see me changing it in anything other than multiples of 10. So I won't be changing it by 5s, for example. And as you can see, that's successfully drawn my red square. Now, all we need to do is duplicate this and set the position to the correct location for the next red square. So I know that my square is of the same size for each of the 4 squares, so 70 is going to stay the same. But now I can use my canvas to identify the midpoint section of this square, which is roughly sitting at 250 and 250, and I'm going to use that to then change my 150 for the first square to 250 for the second red square and run it and see if that works. Now, as you can see, both my red squares have been successfully drawn. As we mentioned, for efficiency, now that the color with the red squares has been used, we can now use the block to set the color to yellow and do exactly the same thing and draw 2 more squares. Again, to speed up the process, I'm going to use duplicate process. So in this case, I'm going to set the position and I'm going to draw the square again at size 70. Now I know that the size is going to stay the same because all 4 squares are of equal size. I just need to check using the grid the positions of X and Y. So again, if I wanted to draw this yellow square first, I can see that this is 250 and this is approximately 150. So let's change that to 250 and 150 and run that and see if I get my yellow square. So there's my yellow square. And then of course what I'm going to do is just duplicate this again, duplicate my draw square again, which of course is going to remain the same. And let's just identify the last midpoint section of my yellow square, which sits at about 150 and 250. Modify that, test it, and check to see if it works. Now, before I run it, it's quite important to also understand that the values, as you can see here, are pretty much the same, except they're just in different orders. So the numbers 150 and 250 are the only two values that you can see are used for position X and Y, except in some cases 150 is set for position X, as you can see in this square here, but then 150 in particular in this example here is used for Y. So there is also a pattern that you can use and recognize. So let's run this for the final time with hopefully all the 4 squares being drawn correctly, and as you can see, the answer is correct. Did you get that answer? Did you use the grid to help you? Well done if you did. Now let's look at the solution provided on the website. So as you can see here, the solution that we've created is the same solution that has been given to us on the website. However, it's important to highlight again that this is a possible answer. As mentioned previously, you could have drawn one red square and then one yellow square and then another red square and then another yellow square, but that would have required you to change the color 4 times, which of course would have added up a little bit more time when creating the final solution. However, that still would have got you the correct answer. So bear in mind that even though we do have the identical solution to the solutions provided on the website, it is still just a possible answer and not the only answer that you could have created. Now let's look at the question called Reach the Wall. This is the second question in the section of Level B difficulty questions, so the second one out of the 4. Now as you can see here, the task says that the turtle wants to touch the furthest wall. Using no more than 5 programming blocks, write a program to help the turtle to get to the wall furthest from its starting position. Note, some blocks count as more than 1 block. So of course it's really important to take the note into consideration, as the restriction here is that we are not allowed to use more than 5 programming blocks. As you can see here, there are also slow, normal and fast options when testing the code and the movement of the turtle to help us test in different speeds. Now let's have a look at the blocks provided to us. So there's 2 types of blocks. One is a movement block and one is a loops block. Now the loops block is there for a particular reason. This means that in some way, shape or form we do need to consider the fact that we may need to repeat certain steps that the turtle takes and thus use the repeat block to help us do that quicker. Now, depending on which way you want to go, you can see that first we have to sort of visually solve the problem ourselves so that we can code it correctly using the blocks provided. Now, the furthest wall is the wall up here. This means that we need to avoid this wall by either turning left or right. Now, again, it's clear to see that you can either turn left or right and still reach the furthest wall. So in this case, there is definitely more than one possible answer. Now, depending on your preference, you will pick either to move left or to move right, but the logic behind the answer will still remain the same. So in my case, I'm going to decide that I want to turn left. So if I quickly run it, you'll see that my turtle quickly turns left. Now, in order to avoid this wall here, I obviously need to make sure that I also move forward. So let's have a look here, run this and move forward. Now, as you can see, now I have the possibility of repeating certain movements. So in this case, I'm now going to look at some of the repeat or looping blocks that I can see. And I can see a repeat block, which is quite helpful. So what I'm going to do is I'm going to pull that block out, and I'm also going to look at some of the if blocks. Now, as you can see here, this is very, very helpful. This is because this block basically does the hard work for me. What it says here is that if there is a path ahead, then move forward and carry on. And if there isn't, then of course I'm going to do something else. Now, as you can see, I need to fill in the block for the else section. This is quite clear to understand. If I can't move forward, then I need to do something else. In this case, I would then be turning right. That's because initially I've turned left, and as I can see a path to carry on, before I reach a wall, I would need to turn right and then continue all the way up to the furthest wall. So I'm going to go over to the movement block, and then I'm going to use the turn right block to put into the else section. Now, of course, before I start moving forward in any way, shape or form, I need to make sure that I turn left first. So turning left is the first step that I will use, and thus it will remain as a separate block on its own before I repeat any of the other options here. So here is a possible solution. Let's run it. As you can see, the turtle's turned left, hit the wall, and I've now received the correct answer as confirmation. Did you solve it this way? Let's have a look at possible answers. So as you can see here, we've essentially got exactly the same answers to what we've done, except our turn right and turn left blocks are in the opposite place. This is because, as I explained previously, there are multiple ways of solving this question, and in particular, there's two ways that the turtle can turn in order to successfully still reach the final goal, which is the furthest wall away from it. So we can also emulate this same answer. The thing to do here is if you or I chose to turn right first, that would become the first step. But of course, that would mean that once we did reach a wall, we would need to turn left instead of right, as previously shown in my solution, to make sure that we finally hit the wall that is in the correct ideal location and not in the incorrect one. So as you can see here, that was the demonstration of the solution provided on the website. Of course, the previous demonstration shown to you was also the solution provided by myself. So again, keyword being possible answer. Well done if you solved that correctly. Now let's look at another level B challenge called heart. Now this question is quite interesting because the blocks are already given to us, we need to rearrange them. So let's have a look at the question first. It says Aaron is distraught. Oh no, there are no more blocks left and those I used to make my heart shape have all been moved around. The task here is to rearrange the blocks provided to rebuild Aaron's program. The program should exactly draw the heart shape faintly below. Now the only information shown here is the hide menu button, which has been shown in almost every question, so that is not of any particular technical help. But it is quite helpful to look at the shape provided first, also then to look at the different types of blocks that have already been filled out for us. Now, all we need to do is rearrange the code. This means that we do not need to specifically write any code or even modify any of the values or numbers provided here. So I'm just going to hide the menu quickly and zoom back in so we've got a little bit of space to work with this. Now, it's really important to, before you start moving blocks around, we look at the blocks that have been provided to us and try to figure out what each block is in relation to for the shape. So for example, there are two repeat blocks here. Each of these are moving forward and turning left for the same amount of moves and a similar amount of times that it is being repeated. Now, as you can see, a heart is a symmetrical shape. So this basically gives us the idea that one block of repeat code is in relation to one side of the heart and the other block is in relation to the other side of the heart. So we know that somewhere in our structure, there's going to be a block here and there's going to be a block here. And then we can start to think about the fact that we need to then fill the blocks in between with other instructions to allow us to create the shape correctly. Now, the first thing I notice here is my starting point isn't in the best location. This means I need to look at the starting location to be a more helpful location. Now, in this case, the intersection here is quite helpful. So before the turtle can start drawing anything, I need to move the position of the turtle back a little bit. This means I would need to use the pen up to avoid drawing anything, move back, as I can see, which has already been provided for me here, and then put my pen back down. This means that I will move back without actually drawing anything, and then when my pen is put down, I'm ready to start creating my shape. Now, the rest of the blocks here are again our two repeat blocks, and actually if you look at it, there's only 4 other blocks that are of similar style left. In this case, move forward 130, another move forward 130. So I'm just going to move here and here just to sort of link it together. This means that these two sections of blocks are generally identical. Now, as you can see here, these are both turn right blocks, except the numbers are different. So it's important to understand that in this block is of course turning right in a lot more degrees than this block over here. So let's, for trial and error sake, move this block here so that my pen or my turtle will turn approximately 180 degrees to the right from my intersection here. Now I can run this, which is very helpful. But as you can see, because I already have pre-written repeat blocks, my code does start to execute those blocks, and that's not very helpful. So the way to do this, or to help us do this, is to disable the block. This then allows us to stop the repetition codes running just for the sake of us being able to test the code that we do feel like is the correct solution. So if I run this, you can see that my other blocks that I have not disabled yet are also affecting my ability to test my code. So I'm going to go ahead and disable everything except the 4 blocks that I would like to test. Now I can run the code, but I can also use the next step. So if I reset this, I can actually click next step and see step by step what is happening. Now in this case, I can see that the pen's moved up because nothing's been drawn between the process of me starting from here and moving back 100. I can see that moving back 100 has allowed me to reach this intersection. And of course now my pen is down. This means that any movement that I do make will actually create a line. So if I go to the next step, you can see that I'm now turning right by 180. Now remember, I just moved this block here to test, but I can see that 180 is the same degree that creates a straight line. So in this case, I can see that my little pointer is actually facing downwards, and that means in the next step, my heart will start drawing a line straight down, which of course is incorrect. This leaves me to look at the other turn right block and swap it around to have a look at whether 47 is actually the correct degree angle that I need to turn. So if I enable this block and I disable this block instead, I can now reset and use the next step button to see that actually now my pointer is pointing in the right direction. So I'm ready to draw. Now, again, using the process of elimination and disabling and enabling the blocks, I can see that I need to do something first before I draw this curve. Now, before the curve arrives, I can see that it's a straight line this way and a straight line this way. So essentially, I need to move forward. So I can see here that there are 2 move forward blocks, both that are exactly identical in terms of the number of steps that they move. So I'm just going to enable one of them, put them in, and then see how the code works. Again, you can run it quickly if you would like to test quickly, but you can also use the next step if you find that you're having errors or you want to go through it very slowly. Again, you can also slow it down in terms of the speed of execution through the slider. So there's lots of ways to help you debug your code. Now, I can essentially see here that I'm creating a curve. Now, it's kind of easy to see that the 2 repeat blocks now need to be used. So I'm going to take this one and I'm going to enable it. Remember, apart from the 114 and the 113, there is hardly a difference between the 2 repeat blocks. So again, for testing purposes, I'm going to put this block in and I'm going to run it and see what it does. So as you can see, I've got my straight line, and now my repeat block is repeating a large number of times a certain type of line. Now I can see, even though it's doing it quite slowly, that it's at the moment successfully following the faint line to create the curved edge on the top right side of my love heart. So I'm going to speed this up a little bit just so I can get to the end of where my drawing is, and as you can see, I've now reached the top middle intersection. So this is really interesting because now I would need to use, knowing what this loop does, the second loop in order to create the second curve. So it's clear to see that my turtle was not facing in the correct direction before actually drawing. Now again, this means that I would need to use the only remaining turn right block, which most certainly wasn't the correct one when we used the previous one, and put that into this section here. So let me disable this block again and just test the turn right block and see what that does. Before using it, I would like to check that the loop will be correctly executed on the right part of the line. And as you can see, I know it's a little bit difficult to see because there is also a line drawn here, but now the location of the pointer is almost in the right direction, ready to start turning for my curve, which is of course my next repeat block. So I'm going to push that block up there and I'm going to enable it. And of course I can run this, but because this is the last block left, I'm going to enable that and put it in as well. Now let's run this at full speed. And as you can see, I have successfully managed to figure out how to draw this shape using the blocks that were provided to us before. How did that go for you? Were you able to figure out the answer? So let's have a look at the solution by clicking here. as you can see, we do have exactly the same solution. Now, the reason for this is because there is only one possible answer. This is clearly because of the fact that you are given pre-existing code and blocks, and you only are expected to rearrange them into the correct order. Therefore, this question only has one correct answer. Now let's look at the explanation. It does clearly say here that it's important to get this perfect so everything lines up just as Aaron wanted. A difficult bug to spot is if the two loops are the wrong way round, the lines do not perfectly line up if the 113 loop comes before the 114 loop. But careful observation is required to see this when it is not marked as correct. So let's actually have a look and do that. So as we mentioned, there was a very slight difference between the two loops. The difference here was the number of times it repeats. So let's see the impact of swapping the loops around on the final shape of the love heart. So I'm just moving it around and I'm just going to run it quickly and let's see what happens. Now, as you can see, the lines at the end do not line up. And this is because that very faint black section there is that one missing step between 114 and 113. Now you're probably thinking you could just change a 113 to 114 and add an extra step, but the trick to this question was that you needed to use the blocks given to you. So you weren't able to actually change that number to 114 and equalize it. And that's where this question was slightly difficult, because it needed to then be in the correct order. So let's move it back and make sure that it is in the correct order to avoid those two lines not aligning up and leaving that one small black space that is exactly equal to the amount of one step. Looking further at the explanation, it does say that the task has been changed, as this was the previous challenge, to bring it back to the intended level of difficulty. The provided blocks were completely separated, whereas now this is not the case. The text below applied to... So in the original challenge, even the loops had the code that was given to us inside correctly in the correct order separated. Of course, that would have made the question a lot harder, because it would have meant that you could have possibly swapped these two blocks around when filling in the correct order, and that, if we run it, would have of course caused another bug in your code. Okay? So as you can see, that one hasn't been marked correctly. So it therefore says an even more difficult bug to spot is if the move and turn blocks or in either of the two repeat blocks are the wrong way around, just as I demonstrated. At this point, the students debugging this problem need to notice that it's going to have a small effect. So it's really important to understand that really it does almost look like the loop and everything has correctly been replaced, because the heart looks like a heart. But if you zoom in, you can see that it doesn't quite line up, and you can see the faint grey line on the left hand side isn't actually matched up correctly. And this is purely because we've turned left first instead of moving forward. So this is a really interesting question, because it highlights how important it is to put blocks in the correct order, and also how small slight changes can impact your final solution, essentially making it wrong. So swapping those back means that that grey faint partial line that we can see is actually no longer visible. As we zoom in here, you can see that, and that's because those two small blocks being swapped over actually results from an incorrect answer becoming a correct answer. So looking back at the bottom, it does say that the two things that are really important to look at is the fact that we need to make sure that the loops are swapped correctly and that the contents of the loop are also swapped correctly. This means that the order of the answer is really important. And also, running the program at hair speed should get to the solutions quickly, which of course we did, because we tested it very quickly to see how our answer would show up. Considering that we obviously also have a time issue in this challenge, using that slider function is really helpful. Let's look at the hexagon question, which is the final question of category B in terms of difficulty. So in this task, we need to write a program that draws the hexagon shown below. You are not allowed to use more than 6 code blocks. Now, the first bit of information is the same information being provided in most of the questions, which is to use the button hide menu to create more programming space. The second and third bits of information are very helpful. The second one says that the turtle will need to turn 60 degrees quite often to draw a hexagon, and the third says that the size are length 100. Now let's first have a look at the turtle blocks that are provided to us and the loops block that are provided to us. Now, the fact that the loops block has been provided to us, and that too with only one specific block, we know that we are going to have to use this block in our answer. Now, to create the connection between the repeat block and our answer, we can see the information. We have been told that we are going to be drawing a turn of 60 degrees quite often. This highlights to us that that is the particular instruction or code block that we are going to be placing in our repeat block. Now, we know that the sides are a length 100. What this means is that when we move forward with the turtle, each time we move forward, we're going to be moving forward by 100. This again is another piece of code that we are going to repeat. So we understand that 60 is going to be repeated at some point and 100 is going to be repeated at some point. We also understand that we're going to be repeating a certain number of times. Now in this case, because we know that this is a hexagon and a hexagon has 6 sides, we will be repeating drawing each side of length 100 6 times. So let's pull out the repeat block and let's put that here and let's change that to 6. Now again, using our understanding of shapes, we know that the repeat block is going to do that 6 times because we have a shape with 6 sides. Now the first thing we need to do is we need to move forward. Now we've already been told how many steps we need to move forward by, so we can go straight over and we can change that to 100. Now let's run this and see what happens. Now as you can see, my line continues to repeat 6 times and draw upwards by 100. To check that this is exactly the amount of steps that I do need to move forward for each side, I can for now use the disable function to disable the repeat block, move this block out and just run it to see if I get the right amount of movement on the side. As you can see, I have moved the correct amount of movements to create one of the lines in my hexagon. Now, this means I definitely need to move forward by 100 6 times. But in between each movement forward, I also need to turn at a certain angle in order to create the correct move and turn in order to create my final shape. We could, of course, turn right by 90 as a default value and run it and see what happens. So of course I need to move forward first and then turn right. So I'm going to swap those blocks around and I'm going to run it and see what happens. As you can see, this of course is creating a square. This is because the turn right of 90 degrees isn't the correct amount of degrees that I need to turn. Instead of using trial and error to create the correct turn by moving these numbers around, what I can do is I can reset this and I can look at the fact that I have some mathematical knowledge about a hexagon. Now we understand that a hexagon has 6 vertices, and because we are looking at a hexagon that has equal amount of sides in length, we also know that each of the angles here and the outer angles here when turning will be equal. We know that the inner angles of a hexagon all amount to 120. So what this means is this angle here is 120. So is this angle here, this one here, not forgetting this one here, of course, this one and this one. We can use that information to our advantage because once we get to this spot here, we aren't turning around this way, but we are actually turning around from this point onwards this way. So if we use the information of 120 being the internal angle and then identify that actually we need to turn the number of degrees it creates in the external angle each time we get to a point or an intersection in the hexagon, we can identify the exact turning that we need to make without using trial and error. Now, as you can see here, I can draw an angle straight here, and this straight line is 180. Now, if I know that the inner angle here is 120, then of course the remaining angle here is going to be 60. This is because, of course, 120 and 60 makes 180, which is your straight line. So let's go ahead and actually put 60 in our turn and see what happens. So I'm going to change T and then I'm going to run it. Let's have a look. Now, with the use of the repeat block, I'm taking 2 blocks, moving forward the correct length as given to me, turning, of course, 60, which was also given to me, but also now mathematically deduced, in order to create the hexagon correctly. Did you understand the maths behind that question? Were you able to make the connection between shapes, angles, and how to draw this question most effectively? Well done if you did. Now let's look at the solution provided for this question on the website. So as you can see, our correct answer has been saved, and another possible answer provided on the website is exactly that we did on our example, as seen above. So the key word here is that it is a possible solution. Now ours does happen to be the same as the website's, but there is other ways of solving this problem. So this again is a possible answer, but not the only one. So let's have a look at another question. Now this question is the second to last question of challenge level C called buried treasure. So this is going to be of slightly more difficult standard compared to the rest that we have done so far. So let's look at the question. The question says, somewhere in the garden is a hidden treasure, but the turtle doesn't know where. It looks like it will have to search everywhere. The task is to write a program to help the turtle search for the hidden treasure. Now, we have a very simple turtle diagram here. The turtle is located at this place right at the beginning. We can see we have some options, slow, normal and fast, which will of course help us to test the code. The idea here is that somewhere in this green space, which represents the garden, there is hidden treasure. But because we don't know where the treasure is, we need to code the program in a way that the turtle can check every part of the garden. Now, it's important to understand that firstly, we only have 5 blocks to work with. And because we have repeat blocks, we know that we will most certainly be using them in order to repeat certain movements to make searching for the hidden treasure more effective and efficient. So, let's first plan out the method that we will use in order to find the treasure. Now, the turtle can go in different ways. We can get the turtle to turn, go all the way up, come back down, go back up again, and come back down. We can also get the turtle to move forward in the direction it's already facing, and then get it to turn left, go back down, turn right, go back down. But you can see that in the both possible solutions that I can plan, there is the idea of a zigzag shape taking place. This zigzag shape will basically allow you to make sure that you cover every aspect of the garden in order to make sure that we search everywhere for the hidden treasure. So, as you can see, we need to move forward. We need to move forward a certain number of times. So the first thing I'm going to do is I'm going to use the repeat and move forward block, and I'm just going to run it to see how many times my turtle is moving. Now, as you can see, it seems like 10 is far too many steps. So if we have a look, we could probably move it down to 5 and see if that is enough, too much or too little steps for the turtle to turn. Now, as you can see, the turtle did actually stop just before the last step that it needs to take. This indicates that the number of steps going along the width and the height of this particular square is 6. This means that any time I repeat moving forward, it will be done 6 times. So if we run this code now, you can see that my turtle has moved forward 6 times and has reached the edge of my garden. Now, of course, when I reach the edge of the garden, I then need to turn left and then turn left again in order to move forward again. Now, turning left is a movement that we can use from the block here, okay, and we can test. So if we have a look here, we can see that our turtle moved to the end, turned left, and was ready to either move forward, but in our case, that would then miss this part of the garden, so therefore we need to turn left again. Okay, now let's run this again and see if that works. It doesn't necessarily mean that just because I have planned it out in my head, that is exactly the correct answer. Now, as you can see, that if I run it, I go forward, I turn left, and it's actually turning back left again. This means that I need a block in between my turn left, the first one, and the second turn left to allow my turtle to actually be in the correct location for it to then actually move down this second zigzag section right here. So I've put a move forward block in between. Let's see what that does. And as you can see, my turtle moved up to here, then turned left again, and it stopped here facing that way, which meant that I'm now ready to repeat moving forward 6 times. So as you can see here, because I'm repeating moving forward 6 times, I can use the repeat do block to help me do that. So let's run it and see what happens. So as you can see, we move forward. Now we have an issue where the turtle is no longer moving upwards, it's coming back down. This means that once we reach the end part of the code that we've created, we shouldn't be turning left, but actually we should be turning right. This means that I need to have 2 repeat blocks in here. The first repeat block allows me to turn left, and the second repeat block allows me to turn right. So let's modify the second repeat block to move the number of times correctly first, which is 6, because we experimented that before and it worked. But now, instead of turning left and then moving forward and then turning right, we will be moving right instead. So let's turn right, let's move forward, and let's turn right again. Now let's have a look and see how that works. Now, of course, this needs to be here, and as before, we need to put move forward in here because we're only moving forward a repetitive 6 steps. Let's run the code and experiment to see what happens. As you can see now, my turtle is successfully moving up the square all the way to the top, and as you can see, my answer is correct. Did you manage to solve that problem? Well done if you did. Let's now have a look at the possible answer and explanation. Now, this again, as I demonstrated at the beginning, depending on which way you make the turtle turn, is actually possible to have multiple answers. This means that the answer in the website here and the answer that we happen to have is identical. However, this doesn't necessarily mean that this is the only correct answer. So well done if you got this answer, but having a look, it would have been possible to actually turn right first and then turn left. And we could have swapped the blocks that way, and this would have allowed us to still look through the garden completely, but instead of going straight on and then going in the vertical direction, you could have also done it in the horizontal direction as well. So again, there are possible answers, multiple answers to do this solution. Now let's look at the final question in the challenge and the second level difficulty C question called Hilbert hiccup. Of course, this question is now intended to be the most complex question or the most challenging question in this particular series. So let's have a look. Hilbert's curve is a famous fractal design. Like most fractal programs, the code is recursive. This means it contains a function that calls itself while running. The function in this program calls itself several times. The program given below has a single numerical error in it. The task is to debug and fix the code to draw the required pattern. Now, before looking at the information, it's important to understand some of the important keywords that have been provided to us. The first one here is the fact that the word recursive is a complex computer science term, but it has been explained to you in this particular example because remember, we do not need to have coding experience to be able to access and do these challenges. All it means is that it contains a function that calls itself while running. So if we have a look here, here is a function called Hilbert, but there's Hilbert being called again, there's Hilbert being called again, another time and another time. That's simply all it means. So let's clarify that and understand that before we move on to the next part of the information. As usual, it says you can use the hide menu above to make more space. It says you can run the provided code to see what actually happens. It is a good idea to slide the speed to hair when you need to submit the answer, but this will be far too fast for debugging and the answer will not be submitted until it has finished running. So this is just telling us ways that we can debug the program in the best way possible using features of the actual canvas provided. So things like the hair, the running, and obviously the next step. And obviously slowing down and speeding up this slider here allows us to check each step carefully and thus identify the error that we're already looking for in this task. Now, the final thing to recall is that there is a single numerical error. This means that we are looking only at the numerical values in this particular code. So that eliminates all the other values that are here, such as angle and level, because we don't need to change them. This is because they are not numerical values. So the only possible values that can be changed are numbers that are like this, where it's 0, -1, 25, 25, 15, etc. So we familiarized ourselves with the code, the concepts in the code. The best thing now to do is do what the hint has told us. Let's run the code. Now I'm going to leave my slider at a sort of middle space, so it's not too fast and it's not too slow. And I'm just going to run it initially to sort of see what happens and what kind of pattern it's drawing. So I can see it started drawing a pattern, and the pattern does correctly follow the grey line. But as I can see on the third step onwards, it doesn't correctly follow the line. So I can see that this is essentially the pattern being created, and it is incorrect. So let's reset that, and now let's use the step function to run this one by one to actually see what happens each time the line of code is run, and of course to identify where the error is made. Now remember, when the code is run, the blocks highlight automatically to identify which section is being executed. So let's hide the menu to give us space to look at the code. Let's zoom out a little bit as well so that we can see all the code in one area. Now let's run the code, but this time let's use the next step function to allow us to draw the code correctly and slowly. So I can see that the first line has correctly been traced. Now if I continue clicking the next step, the next line has also been correctly drawn. So let's continue until I see that a line in particular hasn't been drawn correctly. So as I can see here, immediately I can notice that half the line has been drawn, but another part of the line is still remaining grey. Let's see if that gets completed in the next step or if it carries on. Now, if you've noticed a very subtle change here, the pointer is actually pointing this way. This means that my next step is actually going to draw a line in that direction. Now, as you can see, I've identified the error right here. The error is that the line doesn't actually go down the right amount of length and doesn't turn onto the correct grey line because it turns too early. So now let's have a look at exactly where we are in terms of the actual steps. So if I quickly press the next step, to have a look at which part of my code is being highlighted, I can look at the numbers and identify that I'm moving forward. That is very clear to see. Now the first move forward, as highlighted here, is 25. The second move forward, which was correct, was 25. And then I noticed that on the third step, when I moved forward, I didn't quite move forward the right amount. Now I can see here an anomaly. The anomaly here is that the number isn't exactly the same as the first two numbers, which means that 15 is clearly a little bit too less than the 25 required. So let's change this to 25 and see if that actually works. So I'm just going to quickly run it at a medium speed again, so I can also watch my line being drawn at a relatively slow speed. But as you can see, immediately that black line has now correctly ended at the right amount of steps, and thus it has traced the grey line accurately. Now I can see that the first part of the pattern is successfully being followed. So in order for me to check if the entire thing is correctly followed, and as there is quite a lot of pattern to follow, let's speed up to the hair as suggested, and let's see if it actually completes the entire pattern correctly without any further errors, thus allowing us to check if our answer is correct. Well done. As you can see, the answer is correct, and this was actually, despite being quite a complex looking question and the final question in the challenge, a really straightforward modification if you broke down the problem slowly and looked at it step by step and debugged it using the slider function to make it go slower. So let's look at the show answer and explanation section and just check to see if our answer is correct. As you can see here, we did modify the correct number correctly. Clearly this is because the line being drawn was slightly too short and it should have been of the same length as the other two, again, thus being at 25. So as you can see in the explanation, it says that this is a debugging task. The key to these is to be systematic and run tests. So the first thing was to change the speed, which we did. Then it was to run the code watching carefully to see when the turtle goes off course, which we identified as being during the third step. Then it says to pause, go back a bit and use the next step button to see which moment it has a problem, which of course we did together. And it then says note that the code is highlighted in the workspace as it executes each block, which we also used as a very helpful feature. And that should help you spot the errant block which has move 15 instead of move 25. Increasing the speed of the turtle and running the program to the end confirms that the job is done, which of course we did because the pattern was quite large, and of course watching it rather slowly would have taken a lot of time to test the entire pattern to make sure that of course we check it quickly, correctly and efficiently. Well done for getting through all 10 challenges, and good luck for the Bebras Coding Challenge.